Okay. So suppose definition is clear, right, Madhusmita? What is heteroscedasticity? You know it, right?
Yes, sir.
And the practical example which I gave you. Definition mathematically you can write sigma square I means heteroscedasticity, sigma square means homoscedasticity, right? And
Yes,
this is
sir.
one of the important classical linear regression model assumptions, CLRM, classical linear regression model assumptions. So visually also I can show you in a software using software also. So homoscedasticity means basically regression line, the scatter of points around regression line is uniform. Heteroscedasticity means scatter diagram will increase or decrease as x changes. Example, income versus expenditure. So higher income means more variation, which I was trying to give a explanation. So common pattern, if you see, sigma square I is equal to sigma square xi. Variance is proportional to x. Sigma square I is equal to sigma square xi, variance proportional to x square. And sigma square I is equal to sigma square xi, variance inversely proportional. So these are actually three minimum common pattern which you follow. Okay, this is how it will be. Okay, now the question is, what will be the effect of heteroscedasticity on WLS estimator, that is beta 1 hat and beta 2 hat, okay, which you had derived. So WLS estimator remain unbiased, consistent and linear. Okay, but what unbiasedness is one of the important property, consistency is the large sample property, okay, and linearity, because when linearity, unbiased and efficient, so efficiency will be not there, just to remember this. Okay, clear?
Yes.
Because in
Yes,
the
sir.
chapter number 3, if you see, Gauss Markov theorem I have not discussed, but I was more insisting on Gauss Markov theorem. Have you studied Sangeeta Gauss Markov theorem?
No, sir.
That is why I was insisting you, but because we had less time, so I skipped that. Okay. Numerical property I had discussed, but statistical property I had not discussed. Okay. So just I am quickly telling you in this context because it is related over here. So please note it down, and I will be covering also rest of the things. First of all, least square estimates usually have some statistical property which is known as Gauss Markov theorem. What is it called? Markov theorem. Okay. So basically we say this theorem is to find out the best linear unbiased property of an estimator. Best linear unbiased property of the estimator. Okay. Best linear unbiased estimator. Clear? Now,
Yes, sir.
so you must be thinking that B is for best, right? When the OLS estimator will be best? If it will satisfy linear, unbiased and efficiency. Okay? So first is linear, then unbiased, then efficient. Okay? So what is linearity? Linear means it is a linear function of the random variable. Like for example, like dependent variable y in the regression model. Okay. we had written linear function, linear regression function. Similarly, because we had written beta 1 hat plus beta 2 hat xi, isn't it? So it is a linear function. Clear? Unbiased means, what is unbiased? Expected value of beta 2 hat is equal to beta 2. Okay? Already you know expectation, right? It means,
Sir.
suppose for example, if you will draw 30 samples from a population data, and if you will take estimate beta 2 hat, so there will be 30 regression, isn't it? So if you will take the average of this 30 regression, then means 30 beta 2 value, which beta 2 hat value which you got from this 30 regression, so that will be true beta 2. Clear? That is like, I am just mathematically we can prove, but I am just telling you, in short form. If you need the proof, we will do it later once your NET exam is over.
Yes, sir.
So now once a WLS estimator is linear, unbiased, then efficient means what? It should have minimum variance. It should have minimum variance. Okay. So now please note it down. Variance is a very important part. Okay. So I'll write down because I don't think it is written somewhere here. Please note it down. Variance of beta 2 hat will be equal to sigma square upon xi square, and if you will take the square root, so it is called standard error of beta 2 hat. What it is called? Standard error of beta 2 hat. How you will find? You have to take the square root only. So summation xi square. So what is the main purpose of variance? What exactly the variance gives you idea?
Dispersion of data.
How the variability of sample
No,
from
no,
the population.
No. I think I was not clear. I didn't ask you variance only. I asked you variance of beta 2 hat. Like why we need to calculate variance of beta 2 hat. First of all, you should remember this beta 1 hat and beta 2 hat which you had estimated, they are random variables also because they have a probability distribution. Are you getting my point? So because already we know that the OLS estimators, right, which using OLS method you have estimated, so they are basically functions of the sample data. I told you in the numerical properties, right? So it means the estimate will change, yes or no? As I told you, if we draw 30 samples, then obviously there will be 30 beta 2 hat, yes or no?
Yes, sir.
So what is important? Now the question is, if there will be 30 regression and I have to evaluate which regression is better, how I will do? I have to check the reliability of this beta 1 hat and beta 2 hat which you had estimated. Okay. So we need some measure of reliability or precision of the estimators. Okay. Reliability and precision. Okay. That is, please remember this word, reliability or precision. Okay. Suppose you remember we had recently war on Pakistan, right? What is that war called, Sangeeta?
Operation Sindoor.
Operation Sindoor.
Sindoor.
In Operation Sindoor, what happened? in that night, our captains or fighters using rifle, they have actually penetrated some very what you can say, precision based strikes, means exact location they have exploded the what you can say, missiles. Okay, it means, so it is precision, na? So precision means exactly, or they are reliable. It means they are reliable also, those you can say missiles, right? So reliability is very important, yes or no? Suppose they have fired 30 missiles, a particular type of missiles. So if it will not reach there, then there is a precision is lost. Then there is no point. So similarly, when you are estimating beta 1 hat and beta 2 hat, so that reliability has to be there. Now the question is how you will measure the reliability. So measurement of reliability is based on the standard error, okay, or variance. If you will take the square root, then you will get variance. Is it clear? So basically, in statistics, the precision of an estimate is measured by its standard error. Okay. So standard error is nothing but the standard deviation, okay, of the sampling distribution of the estimator. Clear, Madhusmita?
Yes, sir, but I have a doubt. Sir,
Yes.
how the expected beta 2 hat is equal to beta 2 hat?
That is a property, unbiasedness property. We can prove it. Okay.
Okay, sir. Yes, sir.
I will send you the document. If you are interested in the derivation, I will send you. Not a problem.
Okay, sir.
Best linear unbiased estimator proof I will share with you. You please do it. But right now what I am discussing, I have discussed, I told you, let's say that two regression for the similar research problem. Like if you have remember, let's say that we want to estimate the consumption function. Now you both have drawn different sample. Sample 1 Sangeeta has done, sample 2 Madhusmita has done. Okay. Now you two have estimated the regression. Now my job as an evaluator is to check the regression. Earlier if you have remembered, I told you R square, right?
Yes, sir. Yes.
But R square will come later on. First I will check standard error of beta 2 hat. Okay.
Yes,
If
sir.
let's say that regression where the standard error will be lower, okay,
Yes, sir.
I have to tell that regression is a better one in comparison to the other one where the standard error is higher. Clear?
Yes, sir. Yes, sir.
If-
Actually, we take the different sample, and according to that sample mean, we check how the population mean is vary from the various sample mean.
But mean, yeah, kind of you have said.
But in this section, the perspective is changed, sir.
No, I am just telling you very simple question. Let's say that you two people are there, Sangeeta and Madhusmita.
Yes.
Who is reliable for me? How I will come to know?
The one which has low variance, sir.
Yes, simple.
Minimum variance.
That is it. If you are reliable or precision, we say precision. I gave you Operation Sindur example, right?
Close to
Yes.
the population mean. If
Ha.
my sample mean is close to the population mean, it means I have
No,
minimum variance.
no. Yeah, that is fine, but don't bring that right now.
Okay, sir.
Right now, you just remember that there is a method or measurement or mathematically, if the standard error is low, okay, or variance is low, then we will say that that person is more reliable. Okay.
Yes, sir.
if the standard error is low. Like for example, if Madhusmita will come one day at 9, someday she will come at 10. And I told her to come 9, but she is usually 10. Then, but Sangeeta usually, let's say that she is coming around 9:15 all the time. So who is more reliable? Sangeeta is more reliable compared to
Yes.
Madhusmita, right?
Yes, sir.
Similarly, when you are running or you are basically trying to estimate regression from two samples drawn, you have drawn two samples from same population. Please remember my words. From same population. Then we check the reliability of the estimators or precision of the estimator through the standard error. Okay? Is it clear?
Yes, sir.
And variance of beta to hat formula is sigma square divided by summation xi square. Please remember that this xi is the deviation form. Okay? When I am writing this xi means x minus x bar. Clear? Is it clear?
Yes, sir.
Yes, sir.
So, and see why I am telling you, because they are linked with each other. You should know three formulas, important formulas. One is variance of beta to hat, or then standard error of beta to hat, because if you know the variance, then you take the square root, it will be standard error. Then variance of beta 1 hat, the intercept. What is the formula? The formula is summation. Let me wipe it out. I hope you are making a note,
Yes, sir. Yes.
because these are very intense topic. Okay,
Yes, sir.
so it is not that we can just quickly say yes answer, you got the answer, then okay, over. Because otherwise, at least you should remember the terminologies and how it is derived. At least you should know. Variance of beta 1 hat formula is summation. Now, if you will say, sir, whether we need to remember all these formulas? No, not necessarily, but you should know that okay, this is there. Later on, you can, whenever it is required, you will come to know. Standard error of beta 1 hat formula is summation, means square root of summation capital Xi square. Denominator, it will be n times summation xi small xi square into sigma. Okay, so this is the standard error of beta 1 hat. Okay, the intercept. Okay,
Yes, sir.
now another most important thing which you should also remember, this is sigma hat square. This is called standard error of the regression. What it is called? Standard error of the regression. How you find standard error of the regression? So this is the variance. So basically we calculate, like you can say, first this is the variance. So summation ui hat square, okay, error square upon n minus 2. Okay, n minus 2 is basically, because you are calculating for the whole regression, na? So n minus 2 is known as degrees of freedom, df. Okay, and summation ui hat square is RSS, that is residual sum of square. Okay,
Yes,
so if you know summation ui hat square, you can easily find out sigma hat square. Okay, clear?
yes, sir.
Because another also like quick formula, you can note it down, that is summation ui hat square is nothing but summation yi square minus beta 2 hat square summation xi square. Okay, just to remember, there are many ways to estimate this one, means to find, but this is much easier. Okay. So now standard error of the regression, that is written like this, sigma hat. So it is square root of summation ui hat square upon n minus 2, means the square root will be whole. Okay. So basically you must be thinking variance is fine, standard error of beta 1 hat is fine, standard error of beta 2 hat is fine, because it is actually, it gives you the reliability or precision of the WLS estimators. Again, why sir is bringing this sigma hat also? This is also very important summary measure. Okay, one measure is already I told you r square. In addition, sigma hat, standard error of the regression, is also very important. Okay, so if this standard error is as low as possible, as I gave you the example, Madhusmita and Sangeeta. So I will first check step number 1, I will check the standard error of beta 1 hat and beta 2 hat. Step number 2, I will check sigma hat, standard error of the regression. Step number 3, I will check the r square or coefficient of determination, to cross check which regression, who has done better in terms of OLS estimation. Is it clear?
Yes, sir.
Madhuswinta?
Sir, in the second part, as we said the three
Means
things. how
first
to
of all,
check.
first of all let me tell you, then I will take your question. So what I am doing here, basically I am trying to evaluate the regression which is done from the same population. Okay, means your sample is different, but you have, your population is same. So first step is what? You will check standard error of beta 1 hat and beta 2 hat. Second, you will check sigma hat, that is standard error of the regression. Okay.
Yes.
Third, what you will check? The r square. I think fourth one is also there, which I will be discussing, that is f. Okay,
Yes.
f test. But f test will come usually first, because I have not discussed. So I have not actually. Usually we check f first, then 1, 2, 3. Means it is, the sequence is like this. F is first, this is 1, then this is 2, this is 3, and this is 4. Okay, r square will come 4. Why? Because I have not discussed ANOVA, that is why I have not introduced f, so that is why I was not written. So the sequence is clear, right? So these 4 things are very crucial to evaluate a regression equation. Okay, or to evaluate a regression model. Clear?
Yes, sir.
So now, Sangeeta, sorry, not Sangeeta, Madhuswinta, what is your question? Please ask
So
me.
now, sir, my doubt is clear. Actually, I am confused in the second step.
Okay. Second step means, first step is F statistics. Okay,
Yes,
which
sir.
I will come later on. Second is standard error. So the lower the standard error, you should ask me how we will measure if there are 2 regression output. The regression output where the standard error is lower, down arrow, that is better. Means relatively better in comparison to the other regression. Third, standard error of the regression. Again, it should be as low as possible. What is, there is no ideal value, but it should be as low as possible. That is third. Fourth is r square. R square value should be as high as possible, close to 1. This is coefficient of determination. Is it clear? 4 things.
Yes. Yes, sir.
Crystal clear, right?
Yes.
Okay, very good. I will do this by taking an example, as I told you. I will show this in spaces. Okay.
Yes, sir.
So not a problem. Now here what is problem? What is happening over here? You should be thinking that why sir is telling lot of concept when we are discussing the effect of heteroscedasticity on OLS, because our question was originally in the presence of heteroscedasticity blue. Already I told you about blue. Okay, best linear unbiased estimator when if linearity, unbiasedness and efficiency. If an estimator will satisfy these three important properties, then it will be called best. Okay, it will be provided by which method? Ordinary least square method? No. Indirect least square method? No. Why in ordinary least square method it is not there? Because it will not be efficient. Because the variance will be higher, na? So it will be not efficient. Then weighted least square method? Yes. Instrumental variable method? No. Now the question is, you don't know what is ILS. I have not taught you. So weighted least square also I have not taught you. Instrumental variable method also I have not taught you. So now the question is, these three, what happens, how you will estimate OLS estimator using these three methods. So it is a little rigorous process which will take time. Okay, but gradually whenever there is a possibility I will explain you. Clear?
Yes.
Now you just see, clearly it is written OLS estimator remain unbiased, means expected value of beta, conditional expectation will be beta. Consistency is a large sample property of the estimators. Means what? Beta hat will converge to beta if you will increase the sample size. Okay, so consistency is a very important property. Okay, also linear already we have discussed. So now if we will use OLS estimator, then what will happen? The variance will be no more minimum. This is first. So blue property will not be the best anymore, because there is minimum variance is violated. Okay. Additional problem, what will be the additional problem? Standard error will be biased. Means standard error will be usually downward, it is written, but we will not discuss about this whether it will be upward or downward. Rather we will say they will be biased. Okay, variance may increase or you can say decrease, depends. Okay, T statistics and F statistics are invalid. Okay, as I told you. Then confidence intervals are wrong. Hypothesis test will be unreliable. Why OLS is inefficient? So this logic is given over here, but we will not go deep into this issue. Okay, clear?
Yes, sir.
Little intense, but now how in this context also you should know certain things. First of all, how we detect heteroscedasticity. One method is graphical method. Okay, so what you will be plotting just to check? You will be plotting residuals UI hat versus YI hat. Okay, then you will see if there is a pattern. Okay, you will clearly see if there is a constant variance pattern, then you will be able to observe it. I'll show you using the software. Okay, how through the pattern you can easily identify. Okay, I hope you have certain ideas, right? Suppose for example, how I'll show you means so okay, I'll do like this. Suppose for example, as I told you, there will be three scenarios. So this is your UI hat square in your y-axis, and this is your y hat, predicted values of y hat, and if there is a homoscedasticity, equal variance, then it will be like this. Okay, this is a case of homoscedasticity. Clear? Means when you will plot it. But if there will be heteroscedasticity, how it will be? Then you will see. I will just plot it. You can ui hat square, and this is y hat. So how the pattern will be like this. So this difference will increase. Okay, this will be a little wider. Okay, means it will increase and increase. You getting? This is not narrower, it will be little wider. Means this will be like this, and this will be more of like this. Okay, this whole point, this pattern. Clear?
Yes, sir.
So means in the first graph there is no systematic pattern, isn't it?
Yes, sir.
And second part, there is a pattern. It means the error, the variance is increasing, isn't it?
Yes, sir.
So there are other type of graph also, like which we will not discuss. I think like one more will be like exactly parallel, like this one, exactly parallel, like this. Another one. Then quadratic, if it will be quadratic relationship, you will see like this, like this. Then another one will be like this. These two, this one and this one, they both represent quadratic relationship. Quadratic relationship between what? Between ui hat and yi hat. Okay.
Yes, sir.
So then there will be problem. Now why I am telling you all this, because you should know, because we are not going to discuss heteroscedasticity in general. So rather I will be focusing whenever I am discussing a topic, means I will discuss everything related to that, so that you don't have to study again. Okay, because we are having very less time, right, Sangeeta? Is it fine?
Yes, sir.
You have some idea, right, regarding heteroscedasticity?
Yes, sir.
So now what are the tests which are very formal method? One is graphical method, I told you. Just to remember, Park test. What it is called? Park test 1. Okay. So what is Park test? When I will take a data and I will explain the equations later on, when we will study heteroscedasticity in general. Then Glaser, GLEJSER, this test. This is another formal test which is used to estimate heteroscedasticity. Today in the session they were discussing Spearman's rank correlation test, means Spearman's rank correlation, how you will estimate. So this is also another method, Spearman's rank correlation method, rank correlation test. Okay, how it will be done? They are very interesting. Once you finish the UGC net, I will be discussing how we will be doing. We will be doing manually all this, so that you will be able to remember. Okay.
Yes, sir.
Goldfeld, another test is Goldfeld quant test, because question may vary, so that is why you should know. Okay, everything. Another test is Goldfeld quant test. Okay. Then more tests are there. 5. So 5 is Breusch-Pagan. Breusch Pagan Godfrey test, or in short it is called BPG test. Then 6th test, which is also important, that is called White test. White's general heteroscedasticity test. General heteroscedasticity test. Now the question is, how many tests are there? 6 tests are there. Yes or no?
Yes, sir.
Now if you will say, sir, we will just estimate the regression and we don't care to check the heteroscedasticity. So what will happen? Sangeeta?
Sir, again question.
Question is, now let's say that you have estimated a regression. If you have remember today's session, they were estimating using SPSS.
Yes, sir.
But they will not, you don't care about all these tests. Park test, Glaser test, Spearman's rank correlation test, Goldfeld, Quant, Breusch-Pagan, Godfrey test, White general test. You will say these tests are very difficult, I will not do it and I don't care. Then is there any problem? One person, Madhusmita, is very careful. She has checked using statistical scepter, but you have not checked. Means between Madhusmita's inference and you have not checked. So is it going to be different? Means is there any problem?
Yes, sir. Then my parameters will not be blue.
That is one. First of all, if whether parameters blue or not, that will come later on. First, I am asking a very simple question. If I am not careful, or if I am silent about all these tests, or simply I have not checked the presence of heteroscedasticity problem in my regression model, then I cannot say with confidence that my WLS estimators are reliable.
Yes, sir.
Whether blue or not, it will come later on by default. But simple answer is
They are not reliable.
Means Madhusmita will, with confidence, he will say that my WLS estimators are, you see, it is reliable because I have done heteroscedasticity test. Compared to Sangeeta, who has not performed this heteroscedasticity test. Is it clear?
Yes, sir.
Now, when I will be, and there are other tests also, okay? But those are that not, it's not, another one test is there, but I should write it down. But these 6 are most important, okay? Please mug up if you are forgetting. Because they will come somehow. I have seen heteroscedasticity questions are there, isn't it?
Yes, sir.
Because it is a very important part. Na?
Yes, sir.
7th test is, this is not that popular, Quanker-Bassett. Sometimes they will ask this kind of thing which you are not expecting. Expecting that it will be there. KB test. So 7 tests are there. So please mug up. Okay. Although it sounds like little not appropriate, but we don't have any other solutions now. Fine.
Yes, sir.
Now already as I told you. So Breusch-Pagan test, it is written over here. Breusch-Pagan test use LM test. Goldfeld quant test compare variance of the subsample. consequences if ignored means OLS is still unbiased and consistent, but they are not efficient. Standard errors are biased, hypothesis is invalid. Now, what is the solution? Weighted least square method. Now, if you will ask how I will do weighted least square, that is a $1,000,000 question. We need time. Okay. Now, as far as your understanding concept, first you know what is weighted least square, at least the name right now, that the weighted least square approach is needed when there is a heteroscedasticity, and then your OLS estimators will be blue. This is must, you should not forget. Then you can use robust standard errors. This is also very important. White's correction. Then you can use GLS also. Fourth, you can use logarithmic transformation also. You can take log. So then, how you will define weight? It is given like this. So, if it is inversely proportional, then how it will be, and so forth. Okay. So, this is the OLS estimator formula. Usually, OLS estimator, we write X transpose X inverse, X transpose Y. We usually estimate, okay, beta to hat in matrix approach. Okay, don't get afraid.
Yes, sir.
Matrix approach is much easier, but I have not introduced. Okay, are you getting my point?
Yes.
But I will explain you one day. Matrix approach, if you love it, then the derivation you did 3-4 pages. Okay.
Actually, sir, I
Yes,
did
sir.
it in my PG level. I have the notes, but I forgot.
Yeah, it will be only 1 page only. Believe me, matrix approach is the best method.
Yes,
But
sir.
but usually people get afraid, scared of matrix. I don't know why, but yeah, I will discuss later on this. Okay, but right now you should remember what I told you. Where I am putting emphasis on what is the solution of the heteroscedasticity problem. So what is the solution? You have to use weights. Weight of what? Weight of sigma square, means basically you can use Wi is equal to 1 upon xi, okay, and 1 upon xi square, like that. Okay, so you can see over here. So if this model is heteroscedasticity, then you can transform the model like this. You can divide everything. Can you see over here? So this transform model is here, it is written in terms of star. So this star is nothing but weighted least square method, WLS estimation, and this is how you will be deriving. Then this has a minimum variance among linear unbiased estimator. Is it clear?
Yes, sir.
So now the problem is it is not solved by OLS, ILS basic instrumental variable technique. It is solved by this 4 method. Hence WLS, GLS, lowest standard error 3. And in case of, but where are the other methods will work? You should know also that, na? Because others are also there. You must be thinking, na, indirect least square, where we are going to use.
Yes.
Instrumental variable, where we are going to use. So those things, it must be cropping up in your mind. So now when there is an endogeneity problem, we use instrumental variable approach and 2 SLS, 2 stage least square method, not by weighted least square method. Please remember this. And when there is a simultaneous equation, you use indirect least square method and 2 SLS and 3 SLS, 2 stage least square method, 3 stage least square method. Clear? Now things are getting complicated, isn't it, Sangeeta? You are
Yes, sir.
happy with,
Fine,
you are earlier happy with only OLS. Now I have brought many things.
Yes, sir.
So, but don't give up, huh?
No, sir. It is interesting.
So now ILS is there, 2 SLS is there, 3 SLS is there. Okay, but and they are interesting when we will study. If you are interested, I will take you through all this. Okay, and in case of simultaneous equation, you remember WLS is not the solution. WLS is the solution only for heteroscedasticity. Then these four choice are already I have explained in detail. So how you will remember OLS is blue, WLS is blue, GLS is blue. So GLS is blue. Are you getting? How you will means how you will link with OLS, WLS, GLS. In case of homoscedasticity, OLS is blue. In case of heteroscedasticity, WSL is blue. In case of autocorrelation, you will be using GLS, that is blue. Now, both GLS is blue. Okay. So now you have all this in detail. Is it clear now, or I have left anything?
No, sir. Clear, sir.
If I have
Sir,
left,
actually, sir, in both, actually, I do not understand in both GLS.
Both means both autocorrelation and heteroscedasticity. We use
yes,
GLS.
yes,
Okay.
yes. For both autocorrelation and heteroscedasticity. Okay.
Yes, sir.
So now I have tried my best. Okay. So you can like give me feedback. I can improve further. So now question number 6. Given the regression equation y is equal to 4 plus 0.4x, x is equal to minus 2 plus 0.9y. Okay, find the coefficient of correlation. So first of all, yesterday I told you y on x. When I write like this, so y is dependent variable, x is independent variable. Like in this case, when I am running regression x on y, then x is your independent variable dv and y is my iv, not instrumental variable, independent variable. Okay, so now can you find out, Sangeeta, quickly?
Yes, sir. Yes, sir.
Okay, but don't check the answer. Huh?
No, sir.
It will
With yesterday's explanation, I am thinking, sir.
that is right. If you will cheat, then
No,
it
sir.
is
I don't have anything with me right now.
no, it's fine. Madhusudha, find out.
Yes, sir.
You have calculated?
Yes, sir.
Madhusudha, you are gone. Sangeeta has calculated why you are taking so much time. I think Madhusudha is not there.
Madhusudha ma'am. Yes.
She is
Sir,
last.
actually, I forgot the formula, sir.
Why you forgot the formula? Okay. What is
Can I
Sangita?
explain, sir?
Sangita, what is your answer? Tell me.
And my answer is 0.6, sir.
Very good. Not a problem.
Sir,
Let us
can I
see.
explain,
No,
sir?
no, let us see. Quickly, let me see. So that just you verify whether you have done it in this way or not. So I told you byx. We usually say when you are running y on x, then the slope will be called byx. Okay.
Yes, sir.
Please remember that
Yes, sir. Yesterday only we had discussed.
yx will be in the subscript. Okay. Similarly, regression when you are running x and y, then it will be 0.9. So that is bxy. So correlation formula, direct formula, there is no problem. R square is equal to byx into bxy. So already we know how you will get. So simply you multiply. So what is our value? So 0.4 into 0.9, that is 0.36. So R square is 0.36. I think we don't need even a calculator or anything, right? Just we
Yes,
will
sir.
do manually. It will take only 1 second to answer. Then you
Yes,
can
sir.
save at least if this lollipop type question will be there. So you should be able to do it. Okay.
Yes, sir.
So this is clear. This is what you want to tell, right,
Yes,
Sangeeta?
sir. Yes, sir.
But I had done little more in-depth information I have given. Byx when it will be there, because based on what you have learned earlier, so I have tried to relate. So that beta to hat formula, how you will be doing. This one already you know, right? Madhusmita, this one is
Yes, sir.
fine. So this one is similarly you can write in terms of correlation coefficient, this R into sigma y upon sigma x. So bxy, the formula will be changed. Just denominator there it is x, here it is y. Clear? Everything is fine. The property is R square will be always less than or equal to 1. Both slope have same sign as R. This is geometric mean basically. Okay, because we are taking square root. And both line passes through the mean value, the regression line. Okay. So there is no problem. Other thing is fine. Already I told you many times. The range of correlation will be between -1 to +1. R square will be equal to, today only we are discussing, isn't it, Sangeeta? Will be capital R square when? What is this and what is this? Sangeeta?
Sir, capital R square is
Coefficient of determination.
yes,
Coefficient of
coefficient of
determination or goodness of fit.
Goodness of it.
fit.
Today Prafulla sir was discussing also, na? Isn't it?
Yes, sir.
Yes, sir.
Yes, sir.
And but only in simple regression, simple bivariate regression. Okay? Your square of correlation coefficient will be equal to coefficient of determination. Okay? Square of
Yes, sir.
correlation coefficient. This is Pearson's, huh? Carl
Yes,
Pearson's.
sir. Carl Pearson coefficient of correlation.
Yes, yes. If let's say that correlation is 0, it means there is no linear relationship. Please remember that. Always
Yes,
say,
sir.
if you are saying no relationship, lot of people they make mistake. So you are incorrect. So you have to say there might be non-linear relationship. So that is why you cannot say there is no relationship. There is no linear relationship. Okay?
Yes, sir.
If R is plus or minus 1, then there is a perfect linear relationship. Common mistake, let us see. What is the common mistake? Quick method, as I told you, 30 seconds. Isn't it? There will be no problem. Yes or no? Will you able to do it in 30 seconds?
Yes, sir.
Okay. Do one more thing, one more practice. 2 plus 0.5. Madhusmita, this is for you. Another question is there. Are you doing?
Yes, sir.
Is it happening in 30 seconds?
Yes.
30 seconds over.
Taking the square root of 0.6 is difficult, sir.
So that is why I told it is not happening. Okay. So in this case, you have to, what you will be doing? You have to make some guess. Okay, you will square it and see whether it is close. Because 7 into 7 ja, we know it is 49. So 8 into 8 ja 63. So it will be in between that, some number. So if you will just keep based on that only, you will say. Okay.
Yes, sir.
So I will be also doing in the same fashion. But it will be but usually in the question I have seen, they will not ask you something which is not solved by manual
Without
method.
calculator.
Yes. So related question, what kind of relation question might come? Why two regression will exist? Similar calculation will be there. Regression equation from correlation. So this kind of question you can expect. Then now, this is very important. Ignoring heteroscedasticity, WLS estimator, which already I have asked you. So now the answer, I will not discuss the answer in detail.
Yes, sir. Yes, sir.
Ignoring heteroscedasticity, WLS estimator will be biased, inconsistent, inefficient, or all of the above. Don't see the answer, just tell me. Madhusita,
Sir, inefficient.
yes, you need 2 seconds to answer this. So C is inefficient. Already we know that. Unbiased, consistent, but not minimum variance. Okay. So
And
already.
you should also ask us why, sir, because then only we will be able to remember.
Okay, very good suggestion. Why, Madhusita?
Sir,
Because
okay.
I am not asking Sangita because I know you will be able to answer. So Madhusita, why?
Sir, because in the OLS we have a error term is more. So
That term is more. What do you mean by more?
the error term not, but variance is high.
I'll give you 0 for your explanation. You got 0. Sangita, for you. Sangita,
Yes,
tell
sir.
me. Tell me.
Yes, sir. Our parameter is only efficient when we have minimum variance. But if we have heteroscedasticity means we do not have minimum variance, which means we have high uh, maximum variance or different variance. So
Yes.
it will be inefficient.
Okay. So one correction. In case of parameter, you write means you use estimator because it is coming from the sample data. Okay.
Yes, sir. Yes, sir.
Yes.
Estimator. Yes, sir.
Rest other answer is correct. Okay. Madhusita, now you know what is your problem.
Yes, sir.
Why you commit this kind of mistake? Just now we have discussed, na? Isn't it?
Yes, sir. Actually, I forgot about the heteroscedasticity and we only consider about oil.
So this is purely efficiency problem, not bias. Standard error bias test is invalid, but point estimators are still unbiased. Means point estimator means whatever beta 2 value you got. Okay. Very good. Now let's see about this. Match this. This is not in the correct form means question, but we can do unit root, contingency table, regression coefficient, autocorrelation. Now you have to match with DW test. One is DW, second is T test, stationarity. So what we will write is, I will write over here. So first we will write unit root test. You will tell me which is important over here. Which one? Third, right? Isn't it? Yesterday we have discussed na
Stationarity.
Stationary test.
stationarity. What are the other tests of stationarity? Can who will tell me?
Sir, me.
Yes, tell me.
Augmented.
Sir,
First,
decupolar test.
DF. Then ADF.
Augmented decupolar test.
Then ADF. Yes. Then third is
KPSS.
KPSS. Very good. Then Phillips Perron. Phillips PP test. Phillips Perron test. Isn't it?
Phillips Perron test. Yes.
Yes. So then contingency table. Contingency table. Have you ever used contingency table?
No, sir.
I will show you how you can use chi-square test because this will take little time. So today I will not discuss. But you should remember contingency table means basically it will be given like how many frequencies. Okay. Like suppose you have male, female in a sample survey. Means in a survey. So where we write like in terms of frequency. I'll show you that. But remember contingency table when it is there. Second option was contingency table. So it will be fourth chi-square. This is called chi-square. Because chi-square test is a test of independence. Okay, please remember this. Contingency table means chi-square. Just to remember, I will explain what is contingency table. Okay, that is also very interesting. We will do one chi-square test. Okay.
Sir, what is the basic difference between contingency table and Z table?
That is what I am telling. I will take this in the next class.
Yes.
What is contingency table? Okay.
Yes, sir.
But I am telling you the question is not correct. Z table and contingency table, they are completely different thing. If you would have asked me what is the relation between Z, standard normal variate, and chi-square, then this is a relevant question. But what is contingency table, as already I told you, I will explain it later on. Okay, with one example which will take time. But you should know that contingency table means it is related to, you can use, if a contingency table is there, you have to use chi-square to test the independence. Third is regression coefficient. Regression coefficient. How you will check the statistical significance? If you remember, Professor was telling statistical significance, isn't it?
Yes, sir.
So we use t-test for what? Because in evaluating regression, I didn't tell you t-test. I told you f-test. Then t-test is used where? To check.
Sample.
No. To check the statistical significance of beta 1 hat and beta 2 hat. What do you mean by statistical significance? Sangeeta?
Sir,
So first of all, this is null hypothesis, this is alternate hypothesis. If I am saying beta 1 whatever you have estimated, let's say that you have estimated beta 1 hat is 10.5. Okay. So now I am telling you, so beta 1 hat is equal to 0, because whatever the value you got, you are trying to defend this value that you are correct. So if it is not equal to 0, it can take any other value, isn't it? Yes or no? This null hypothesis formulation you have understood, right?
Yes.
Sangeeta?
yes, sir.
Means if I will get 9 also, then that is also fine, because it is greater than, it is not equal to 0. It can be 9, it can be 10, it can take other value, but it is not 0. If it will 0 means, then there is a problem, isn't it? Then why I have estimated? Means my regression is not correct, right? Are you getting? Similarly, because the software usually give this only, this null hypothesis only. Please remember, software will not do the specific test, hypothesis test. we can do it manually, but software usually give this beta 1 hat is equal to 0. That test usually it will give. It will not differentiate what exactly you are going to test. So statistical significance means similarly for beta 2 hat also. So statistical significance means if I will reject my through the test, what is the means decision criteria? I will be using t-test. T-test is how I will be doing, means whatever my beta 2 value divided by standard error of beta 2 hat. Okay, this is my t value. What is it called? T value. Clear? Sangeeta, is it clear?
Yes, sir.
Standard error just now I told you, no? Isn't it?
Yes, sir. Yes, sir.
This will be given. Beta 2 hat is also given. How you will get t of beta 2 hat? You will be just divide it. Just divide it.
Yes, sir.
This is called calculated t value. This is called calculated t value. And what is the tabulated value? You will be writing like this. T, whatever the degrees of freedom, then 0.05 you will be writing. Means at 5% level of significance. I told you one value. Have you remember?
Yes, sir.
What is that
Yes,
value?
sir. Then we have a chance of 95% accepting the null hypothesis.
No, that is fine. But tell me what is the value I have remembered when I told you. What is the t value? 1.96.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
So now, if let's say that you are testing whether beta 2 hat is statistically significant or not. So you got calculated t value is, let's say that you got by using this formula you got 5. Okay. So first usually we take the absolute value. Okay. Whether it is -5 or 5 hardly matters because we will take absolute value. So I'll come to that. I'm just keeping it simple, not making it complicated now. So if your calculated t value is greater than tabulated t value means the critical value, means calculated value already we got 5. So 5 is greater than 1.96. Yes or no?
Yes, sir.
Then what I will say? I will reject my null hypothesis. Then my conclusion will be what? Reject H naught.
Null hypothesis.
Then when you reject the null hypothesis, please remember that. If you will reject the null hypothesis, then the test is statistically significant. Test is statistically significant. Okay? Means what exactly statistical significance is saying? That you have proved that your beta 1 hat is statistically different from 0. Clear?
Yes, sir.
Madhusindra, is it clear?
Yes, sir. Yes, sir.
So statistically significant means you have proved that your WLS estimator, whatever you have estimated, is statistically different from 0. Because let's say that when you will come to me with your regression output, I will ask, is it statistically different from 0? Means I am asking, is it statistically significant? Clear?
Yes, sir.
Clear? This is also, so when you are evaluating regression, let me add this. T-test, first thing you have to check is T-test of the beta 1 hat and beta 2 hat. If they are statistically significant, then only you will interpret the regression. Otherwise, no. After you evaluate the regression, then you will go to the T-test. Is it clear? Means they are like not mutually exclusive, they will go parallelly. If one is not happening, other one will be not also. Suppose if your regression is not statistically significant, So what does that mean, Sangeeta?
But it means we accept null hypothesis.
No, it is not clear. Like the way I told you, explained here. Similarly, right now I am asking F test. So let us discuss that also. In F test, what you are testing? Whether your regression is statistically significant. Then what will be your null hypothesis? Your null hypothesis will be beta 2 hat and beta 1 hat. They are all equal to 0. Means if there will be multiple regression. Here it is only one regression. Because your regression is involved with x only, x on y, means basically y on x, right? X is your independent variable. So you are saying slope is equal to 0. And your alternate hypothesis is beta 2 hat is not equal to 0. Then you will say, sir, already we are doing t test. Why? What is the need of f test then? Isn't it? But you should remember that another clue. In case of bivariate regression, if you will square the t, whatever the value you got, this 5, if you will square it, you will get f. It means 5 square is 25. So clearly I will get f value is 25. Clear?
Yes, sir.
Is it too much? I am saying.
Yes, sir. This is seeming difficult, sir.
Okay. But F test you should remember that we do, so you can remember like this. Why you do F test? First of all, let us ask one by one. Can you tell me, Sangeeta, why we do F test?
Sir, when we have multiple independent
No,
variables.
no. First you remember we use F test to test the statistical significance of the regression.
Yes,
Be
sir.
very clear, then you will be able to understand. We use F test, please note it, to test statistical significance of the regression of the
Sir, this is so this will be true for all the tests, no, sir? So for t test also.
first you I am coming to that.
Okay, sir.
Don't confuse. First you focus here. F test is done to test the statistical significance of the regression. Clear? Is it clear?
Yes, sir.
Now let me write one regression equation. This is very interesting. You will never forget. Okay? When you say that I am not able to understand, then my work starts. Okay? Clear?
Yes, sir.
So let's say that you have you are estimating a regression ya is equal to beta 1 because you have gone only till here beta to x. So I am just writing it in a different way, which I am expanding it to multiple regression. Okay, multiple regression. Multiple regression means more than one independent variable. So I will be writing like this: x2i, x3i, because x1 is reserved for this. Okay, so we start with x2i, x3i, and it will go up to xki, beta k xki. Please remember this. Okay, so F test is basically a method of testing hypothesis about one or more parameter of the k variable regression model. So what are the parameters? These are the parameters, isn't it? I have estimated. Yes or no? Because I told you we are checking the statistical significance. Then next I am telling you in better way. I am telling you we are checking the hypothesis about the parameter which we are trying to estimate. So how I will write? I will write like this. My null hypothesis will be beta 2, beta 3, beta 4, okay, it will go up to like this, is equal to 0. Okay, is it clear, Sangeeta? When I am saying
Yes, sir.
all these are equal to 0 means what? My regression is nonsense. Means I have estimated a regression model which has no meaning. It is a crap. It is a just wastage I did. Okay, means the data which you have estimated or the regression model which you have estimated, it is not making any sense. Is it clear? Is it clear?
Yes, sir.
Somehow I can understand from your voice tone. Okay, so how I will write? Let me write it little generalized form. So it is equal to beta k, because it will go up to, if you will include k independent variable. So basically this is your null hypothesis. I am writing in word also, so that you can understand. All slope coefficients are simultaneously equal to 0. All slope coefficients are simultaneously equal to 0. Is it clear now? You are testing only this. Okay?
Yes, sir. Yes, sir.
Yes, sir.
So now I will ask you a question, because I have taken a lot of effort to make you understand this. When I am writing like this, what does that really mean in word without using much statistics? Just today only refer to Prafulla sir or Prafulla sir's class. Means my x2 has no effect on y. My x3 has no effect on y. My beta k, whatever the independent variable will be included, it has no effect on y. Okay? If my regression, what I am testing, that my regression model, because this is my regression model, isn't it? So x has no effect on y, because we are trying to see the dependence of y on x, isn't it? So x has no effect. Then what is the purpose of running the regression? I will say, if your F test is not statistically significant, then there is no purpose of this. Your regression model is completely incorrect, isn't it? It is not making any sense. Is it correct?
Yes, sir.
Sangeeta, you have understood?
My brain is not accepting anymore, sir.
Why? Where your brain has headed? Which step? Tell me. Means you are feeling sleepy, then I don't have any answer. But if you are fine, tell me in the word which I have written. Just you focus here. The null hypothesis is this. Means what? Literally, what is the word meaning? I have explained. You have understood or not?
No, sir.
No. When I am saying, because null hypothesis is what? I am hypothesizing, right? Which is yet to be tested, right? Right? Null hypothesis you have understood, right?
Yes, sir.
So when I am saying, what is your purpose of regression? Can you tell me? Means why you are estimating regression?
To know the effect of X on Y, sir.
Very good. You are telling the answer only. You are trying to estimate the regression to know the effect of X on Y. Now when I am saying, the moment I am saying beta 2 is equal to 0, is there any effect of x2 on y?
No.
Then you know the answer. Then what is the point of estimating the regression?
No point, sir.
Are you getting my point?
Yes, sir.
So F test is done just to check overally whether your regression is making any sense or not. Is it correct now?
Yes, sir.
Or still it is not clear? Tell me.
Yes, sir.
I have not lost hope. Okay. So
Sir, just one doubt, sir. Here, this beta 1, beta 2, we are calling parameter or estimate, sir?
parameter. You can use beta 1 hat, beta 2 hat, not a problem. You can use alternatively. Are you getting my point? But usually when we test, you are correct. When we test, we because we are hypothesizing, because population regression function is the first point. This is population regression when I am not using hat. Whenever there is no cap means it is PRF, right? So
Yes, sir.
ultimately we test PRF only. But in t-test, whatever I have written, that I will be whether I have written anything different way. T-test. Why you got confused then? Sangeeta? Parameter and estimator, why you got confused?
Sir, previously I had answered, so you told that do not say parameter, say estimator. So, sir, that's why I asked.
Okay, okay. I got it. So I told in a different context because T, when I told you calculation of T, because that time I told you beta 2 hat upon standard error of beta 2 hat. Okay. Why I told? Because true beta 2 is unknown, na? Isn't it?
Yes,
Are you
sir.
getting my point? Is it your doubt is clear or not?
Yes.
But always you remember that whenever we test, okay, you have rightly brought a very important question. So your null hypothesis will be always with respect to your parameter, not estimator. Okay, because you start with, because that is what you have hypothesized, na, your relationship, functional relationship. Are you getting my point? Yes, of course your alternate hypothesis will be means you can say beta 2 is not equal to 0. Yes, don't use hat in writing the null hypothesis and alternate hypothesis. This is clear or not?
Yes, sir.
Or is there any doubt? You ask me, even if it is a silly question.
No, sir.
Madhusudha?
Sir, as you said, why you do not hat the beta 2 1 and beta 2 hat here in the null hypothesis and alternative hypothesis?
Because we have started, if I remember, in a regression we have started with PRF, na?
Yes, yes.
PRF is the functional hypothesized relationship between, let's say, that consumption and income. Means you are trying to test that beta 2 is 0, means there is no effect of income on consumption. Are you getting?
Yes,
That
yes,
is a theoretical relationship. But what you have observed from sample is a sample relationship. Means it is coming from the sample data only.
yes,
And
sir.
through beta 2 hat, you are trying to prove what is beta 2, right?
Yes, sir, yes.
Are you getting my point? Now
Yes,
you will say in hypothesis testing, why you will write beta 2? But yes, they are unknown, but you know only beta 2 hat only. So ultimately you are going to use beta 2 hat only. But you will be writing like this. Why? Because you are telling about the hypothesized relationship regarding your population parameter, not estimator. Estimators, through estimator you will be saying something, drawing inference regarding the parameter. Is it clear?
yes, sir.
Sangeeta?
Yes, sir.
Now I think it is little getting clear.
Yes, sir.
Yes,
Because
sir.
your voice tone is changing. Okay?
Yes, sir.
So now we will come back to F test. So in F test, when I am writing like this, so when my null hypothesis is beta 2, beta 3 is equal to 0, it means all slope coefficients are simultaneously 0. Then what will be my alternate hypothesis? If you have understood, tell me. If my null hypothesis is this, all slope coefficients are simultaneously equal to 0, then what will be my alternate hypothesis here?
Not equal to 0, sir.
Very good. So I will write like this: beta 2, beta 3 equals to beta k is not equal to 0. Or in word, what I will write? Not all slope coefficients are simultaneously 0. Slope coefficients are simultaneously 0. Simultaneously 0. Is it clear?
Yes, sir.
It means in the null hypothesis I am saying, if whether I am checking all slope coefficients are simultaneously equal to 0. When I am saying this, it means my regression is useless. Whatever the regression you have done, it is useless, or it is statistically not significant. Please just focus on my emphasis on the word what I am using. Okay? When I am telling that the slope coefficients are simultaneously equal to 0, it means they are statistical, the regression is statistically not significant. But here, when I am saying not all slope coefficients are equal to 0, it means if I will reject my null hypothesis through the test, how I will do the test? F test. Okay? F test formula is ESS upon degrees of freedom divided by RSS upon degrees of freedom. Okay? What is the F test formula? ESS upon DF, RSS upon DF. Okay? ESS degrees of freedom is K minus 1. K minus 1. And RSS degrees of freedom is N minus K. What is K? K is the number of parameter which you are estimating. Clear?
Sir.
Now, if you have proved, you will reject the null hypothesis, then what you are trying to prove? That whatever the regression you have estimated, it is statistically significant. It means my slope coefficient, let's say that you got beta 2 hat, you got 0.5, then it is fine. You are saying this 0.5 is fine. Are you getting my point? Sangeeta? Huh?
Yes, sir.
Sir, can you again explain it?
Because I am saying my H0 is all slope coefficients are simultaneously equal to 0. It means my regression is nonsense. I have run a nonsense regression. There is no impact of X on Y. Are you getting my point?
Yes, sir.
When you will come to me with your regression output, I will ask you, is the regression is making any sense? You will look at the F test value. Okay, the moment I ask you this question, then you will prove, no sir, my regression is making sense. How? You just look at my F value, it is very high and with low P value, so that is high. I know that my regression is statistically significant. Then you will go to the other three parameter which I told you. Standard error of the regression, then R square, right? Only when your F test is statistically significant and the P is less than 0.05. Okay? Clear, Sangeeta?
Yes, sir.
There is no point. If your F test is if it is not statistically significant, means your all slope coefficients are equal to 0. Means you have done a bakwas regression. You have no idea about the regression, or your regression is not making any sense at all. Is it clear?
Yes, sir.
So first you will look at F value, then you will go to the other criteria, other three criteria which I have already discussed. Is it clear?
Yes, sir.
Yes, sir.
Okay. You just see how much the regression, the discussion is very intense. But I hope you understood this, right?
Yes, sir.
Don't worry. I'll. So this is basically called testing the overall significance of the multiple regression or any regression coefficients. Okay. Because in bivariate I told you the relationship is f is t square is f. Okay. And there is a relationship between also r square and f, which I will be telling you tomorrow, but today it will be little heavy on you. Okay. So is it clear?
Yes, sir. Ranchi ko hindi tha, sir.
Okay, we will complete this. Autocorrelation means D is autocorrelation.
Durbin-Watson test.
Durbin-Watson test. Now A3,
Not
B4,
unit test.
C2, D1. It is clear?
Yes, sir.
Okay. I'll stop over here. You ask me any question tomorrow.